Determining the percent composition of silver in a 1945 dime. My name is Andy.
And my name is Justin. Okay, so the purpose of our lab is to investigate the percent composition of solids, and the percent composition is the percent of total mass of the compound or alloy in each constituent element, and we're going to determine the percent composition of silver in a 1945 U.S. dime made of silver and copper. And percent composition allows us to do many things, like determine the empirical formula, and it's also important in metallurgy for alloys.
So some background. After doing research, we found that a 1945 US dime is 90% copper and 90% silver and 10% copper. And so our goal is to isolate the silver and determine its mass so we can find the percent silver of the dime. We're going to do this using these two reactions. Firstly, we're going to dissolve the silver using nitric acid and to form a soluble silver nitrate, water, and nitrogen dioxide gas. And then we're going to take this silver nitrate and react it with sodium chloride to form silver chloride, which is insoluble, sodium nitrate, which is soluble, and also copper chloride, which is soluble, so copper will not precipitate out.
Okay, so the hypothesis for this lab is, given that the 1945 US dimes are 90% silver, our dime should report results close to 90% silver by mass after the silver is isolated by precipitation. This is because precipitation should, in theory, have 100% yield in isolating silver.
Methods. So before we dissolved the dime, we first found the mass using a balance. Then we assumed that the dime was 100% silver and added at least twofold excess of nitric acid needed to dissolve the dime. The solvation process took a while, so we waited overnight for it to completely dissolve. And if it doesn't, apply heat if it's necessary to speed up the solvation. A note of caution, concentrated nitric acid is highly corrosive. Silver nitrate will also cause burns, and nitrogen dioxide gas, which is formed, is toxic, so be sure to conduct this in a fume hood. Also note that assume the dime is 100% silver when determining the excess nitric acid and sodium chloride needed to react.
So to determine the precipitation of silver, we added twofold excess of sodium chloride to the solution and stirred it to speed up the precipitation. And then we used filtration to filter out the precipitate. And so we found the mass of the piece of filter paper first using the electronic balance. And then we used the Buchner funnel and flask to filter the precipitate out of a solution. And then we allowed the precipitate and filter to dry and found the mass of the precipitate and filter paper.
So this is the data we got. As you can see, we found the mass of the dime, the mass of the filter paper and precipitate, and the mass of the filter paper itself. Also here are the excess reactants that we used, the 10 milliliters of nitric acid and 0.7568 grams of sodium chloride.
So the excess reactants were first determined.
The excess reactants were determined by stoichiometrically. So we use two times excess of nitric acid is 3.36 milliliters. So we used a lot more than that because we had trouble dissolving our dime, and the excess of sodium chloride was 0.590. So we used slightly more than 2 times excess too.
Okay, so our calculations were, first, we weighed the mass of the silver chloride by subtracting the filter paper from the total mass after the precipitation, and then we found the mass of silver by multiplying the total mass of a precipitate by the percent silver of AgCl, and then we found the percent composition, which was 92.5% silver.
Okay, so from the 92.5% silver that we obtained, our percent error was 2.78%.
Okay, so
after first we dropped percent compositions greater than 100% in the class data because obviously over 100% silver would not exist, and this is an obvious experimental error. And after that, we we dropped the outliers and found that the mean was 88.9% silver with a standard deviation of 3.93%. And so using the mean of 88.9, we had a percent error of 1.22%.
Here you can see the percent silvers on a graph after we dropped the obviously erroneous data values.
Okay, so as you can see, most of the trials were clustered around 87 to 91% silver. Results. So the mean percent composition of silver was 88.9%, and this was close to the 90% theoretical composition with a percent error of 1.22. So this is relatively accurate. Our standard deviation of 3.93 is also pretty small, so we can say that our data is moderately precise. However, of 37 trials conducted, 14 were over 100% silver. So this shows, or this means that 1/3 of the trials were obviously erroneous. After removing the values over 100%, there was only one outlier, which was good.
So our hypothesis in the end was pretty accurate in saying that because 88.9% of the composition was obtained, and so this is very close to expected 90% silver with only 1.22% error, which is relatively small.
So error analysis. Some factors could have decreased the percent composition of silver. For example, not enough sodium chloride could have been added, or not. The precipitation was not given enough time, so the silver chloride may not have completely precipitated.
Okay, and there is also, for any increased percent in composition, there possible reasons could have been filter paper wasn't completely dry, or as the water evaporates from the filter paper, sodium nitrate was left behind in the filter paper because it cannot evaporate, or too much NaCl added to the solution
to make it saturated. So the sodium chloride crystals were filtered with the silver chloride crystals, which would have increased the percent composition. So any of all of these reasons may have explained why so many percent compositions were over 100%.
And in the future, if we were to do this lab again, we would redesign the procedure to remove sodium nitrate from the filter paper before massing, or weigh the AgCl without filter paper to reduce error, or stir the solution in the beaker rather than a test tube to ensure equal mixing and complete precipitation.
And here's the one reference that we used.
Thank you.
Thank you.